Hello everyone, welcome back to Linked Frequency. In this tutorial, we are going to learn about line follower robot using the IR sensor module and Arduino Nano development board. This is the 16th tutorial of PCB practice project for PCB designers, and I'm Vaibhav Sugandhi, passionate PCB designer and technology startup founder. Basically, this tutorial is focusing on creating a most commonly used or designed DIY product, that is line follower robot. Basically, it works on the black color path on the white color surface. When you draw or create a black color path on a white surface, based on the IR sensor reflection, the robot is programmed in such a way that it will follow that particular path based on the sensor result. That's why it is so called line follower robot actually. So now we'll jump into the details of the project by going into the components being used in that particular project. First thing is we need a 2 IR sensor to identify whether the robot needs to rotate left or right, or take turn in the right direction or in the left direction based on these 2 sensors. If we use only one sensor, it is difficult to find where to turn the robot and all. That's why we are using a 2 IR sensor. And then of course we need a 2 DC gear motor, which are very commonly used for such kind of a projects. And then we need a motor driver which will control the motor turning on and turning off based on the microcontroller signal as per the processed data from the IR sensor. And then we need a battery circuit which will power up the entire electronics. And then also we need a 1 microcontroller development board, that is Arduino Nano in our case right now. This is all the project detail or a project planning for this DIY project. I hope you understood what exactly this project is all about, and I hope you got to know the concept of line follower robot. If not, then feel free to check out the couple of videos on the YouTube to understand how exactly line follower robot works. Now we have a black box analysis in front of us. First thing is we need a battery pack which is of a very good voltage and a current rating that is sufficient for the entire project. In our case, we will be going with a 8.4 volt, which we will be discussing in the white box analysis. Right now, we need a battery pack, and then we need a DC power supply, which will convert or regulate the unregulated DC voltage from the battery pack into a regulated DC voltage for our entire electronics. And then we need a right side DC motor, left side DC motor, and then a right side motors driver and a left side motors driver. 2 independent motor driver we are using right now, just because we wanted to make that circuit as simple as possible. If we use a single driver motor or a motor driver, then it becomes a very difficult for you to connect the Arduino Nano development board. Thereafter, we need a main controller unit, and also we need a right side IR sensor module and a left side IR sensor module. This is the most simplistic line follower robot that one can create at the designer level, or maybe a practice project for PCB designer level. Okay. Alright, so this is the white box analysis for our line follower robot. Here we can see that we will be having a 8.4 volt lithium ion battery with a 2 ampere hour of current rating. Why we need a 2 ampere hour? Because we have a DC motor here which will be inductive load on the entire system, and it will consume a huge power when they are working with a high torque. So that's why we need a good amount of battery backup. That's why we are choosing a 2 ampere hour of battery pack. 8.4 volt, why? Because the entire circuit works on the 5 volt. If we take anything less than 5 volt, then it will not work for the entire electronics, because our DC power supply, which will convert the unregulated DC into a regulated DC, will consume some power. So if we give a 8.4 volt, then we will get a 5 volt direct DC and a very regulated DC in a proper way. We will be also introducing a switch in this particular place so that we can turn on and turn off this entire electronics whenever we want. Unplugging and plugging the battery will be a little risky. Why? Because if somebody puts it in a wrong direction, then it will burn the entire electronics. Thereafter, we have a LM7805 as a voltage regulator, which we will be using all the time. Since beginning of this project, we discussed about LM7805 regulator. This is how these regulators are used in real-time application. Thereafter, we have a right BO DC motor. BO DC motor or a BO motor is the one category of a motor which is very commonly used in such kind of a line follower robot. There you can see this small motor here. This is called a DC BO motor, and we will be using that DC BO motor, right side and left side. IRF 540N is the MOSFET, N-channel enhancement type MOSFET, being used in this circuit as a driver on the both side. Actually, we are using a 2 IRF 540N driver circuit, and then we have a Arduino Nano V3 as a main controlling unit. Thereafter, we have a LM358 IR sensor circuit, which we designed in previous tutorial as a right side IR sensor and a left side IR sensor. This is how the entire white box analysis looks like when it comes to line follower robot. Now it is time to go for the designing a schematic and go for the PCB layout. Let's jump onto the easyEDA software. So this is our easyEDA software. Now you can see that I have already opened this DC motor controller circuit and also IR sensor schematic here. Why? Because we are copy pasting that technique or a trick whichever I discussed in our previous tutorial. I hope you remember. If not, feel free to check out those previous tutorials to understand how exactly we can utilize our previous designs. First thing is, I'll go to the file and create a new project, naming it as a line follower robot. And description, as of now, I'll ignore it, but it is better to give a description in case of a new project design activity. So we have a line follower robot here. I think schematic is not created over there. So I'll just create a schematic and I will change it as a schematic. And I'll say this schematic in our existing project, which we just now created. All right. So now I'll change the title to all right, and a company name to linked frequency. And my name is correct one. So good to go. So now the magic part comes into the picture. First thing is we need a power supply which will convert our battery voltage into a regulated DC voltage. Just need not to worry about it. Just go to the DC motor circuit and you have that circuit already ready. So that is the use of using the EDA tool like easyEDA that will help you to copy paste from wherever you are connecting. So now you have the 2-pin connector here, which is of a green terminal connector. Now I think we need to replace this one with the RMC connector so that it is easy for mounting the batteries. So first thing what I will do is I'll delete this one. I'll go to the common library and search for the 2-pin header connector. The male header connector is better for us. So I'll select it and I'll place it somewhere here. I think better to place it, good to place it here only. What I will do is I will copy paste these two because one is for switch, one is for our this one. So I'll change the heading name as RMC_2P. So that indicates 2-pin RMC connector. So this goes to, I'll keep it here. And this one also, I'll keep it outside. Let me change it to RMC2P first. And then we'll place it here. And this RMC connector is our power connector actually. And this RMC connector is our switch actually. So that's why I was just thinking how we can make it better to understand you, help you to understand in a better way. So I just wanted to make it easy for placement, right? So here it is. I think, yeah, good to go. So first thing is our power supply goes to the switch and switch to our diode. Even in case if you connected your battery in a reverse direction, our diode will protect the entire circuit. However, it is better to use that kind of a connector which will avoid you to make any kind of a wrong connection. Now we have a problem that we have 7812 regulator. I'll delete that one as well. And I'll bring a 7805 regulator. So I'll just go here and select a TO220 package and I'll bring it and place it here directly. So then we have everything perfectly set and we need to change this one plus 12 volt to plus 5 volt DC. So this is how our entire circuit is made up of. And again, I have to change this voltage as well because a 100 microfarad capacitor is sufficient for us. And voltage is 8.4. So twice of that is 16 point something, 17.2. But no, 16.8 actually. So instead of that, what I will do is I'll go for the 25 volt capacitor at the input side. And the output side, we know that 16 volt or 10 volt is sufficient and not 100 microfarad, 10 microfarad is sufficient. So this is how our power supply is designed. So this is power supply. We are done with the power supply, the entire circuit here. And then we have a IRF 540 circuit, which is already designed in our previous circuit that is all about DC motor controller. And even Arduino is also along with that. So I'll copy the entire circuit. Pretty much I'm copying the whole circuit in that section or in that project. So I'll keep the Arduino Uno development board or Arduino Nano development board. Sorry for that. It's not Uno, it is a Nano. So I'll keep it aside and I'll connect the ground here because we need a ground there. And then we have left motor control, or I'll say left motor CTRL, which is left motor control, and this one to plus 5 volt. And we have our 2-pin connector. I'll delete this one and I'll bring the RMC connector again, the 2-pin header, and replace the name as RMC_2P. Alright, so I'll just rotate it and place it here. Thereafter, what we need to do is copy paste this circuit because that's what we want, right? So I'll just copy and paste it here. And now it is a right motor CTRL. Okay, a right motor CTRL, and RMC is here and everything is fine. So this is all about the motor controller. And this is our Arduino Nano development board. I'll just keep it aside at this point of time. Now I'll go to the IR sensor circuit and I will copy this entire circuit. Why? Because we need this entire circuit. I'll just copy it and I will paste it somewhere outside just to modify it in proper way so that we can take it inside. First thing is we do not need analog pin right now. So I'll remove this analog pin ka circuit. Why we don't need that? Because we want only high and low signals only. So that's why. And we do not need these connectors as well. So I'll just remove this connector as well. And our VCC voltage is plus 5 volt, which we already know. And the 100 ohm, this is a photodiode, and this one. And this VCC is also plus 5 volt, which we already know. So that's why I'm keeping it a plus 5 volt. And this resistance and this LED both are not required. Why? Because we are connecting it to our microcontroller GPIO directly. So what I will do is I will just directly connect it to our output of the operational amplifier. So what I will name it as left side IR sensor. Okay, LSIR. And this is our final circuit for this particular project. Of course, I need to select a ground as well and copy this one and paste it. Paste it somewhere here only. So I think I'll paste it here. Okay. So now I will rename this one LS2RS right side IR sensor. So this is another circuit. I'll remove this border and a name because we need to modify it anyway. So this is how our IR sensor circuit is ready. Now I think you understood the potential or the importance of easyEDA tool, or not only easyEDA tool, most of the EDA tools will be having this potential just to copy paste or reuse the previous circuit that you have designed in this particular tool. So this will allow you to speed up your design activity and make it much faster. So now I will fast forward the video to make it professionally good looking as we do all the time. All right, now you can see that our entire schematic is ready. As we discussed in our white box analysis, we have our power supply section here with the reverse connection polarity protection, as well as we have a motor driver circuits, IRF, this MOSFET IRF 540 and driver circuit. And also we have our IR sensor module. Two of them are designed in the same circuit. And then we have Arduino Nano development board. One thing is the way how you did the copy paste from the previous project to a schematic window, we cannot do like that for the layout activity. So that's why we have to design the everything from the scratch in the coming PCB layout activity. Before that, I just want to tell you one more thing. Sometimes we can notice that these designators, these are so-called designators, are not updated properly. In this particular circuit, we have only one diode, or maybe we have multiple diodes, but those diode IDs or designators are not properly organized. This one is D1, this one is D3, this one is D2, something like that. I just wanted to make sure that it is all organized in a proper way from this particular point. That we can do by clicking on the annotate option. This annotate option is the very good option which we have to use all the time whenever you are designing the large project, and it has to be done only once in your entire circuit before sending it for the evaluation. So I'll just say re-annotate, and all the pages right now rows wise and columns wise we have an option, but I'll choose a row wise. So I'll annotate it. Now you can see that this one is a D1, this one is a J1, this one is a U1, and if you go here you can see this one is a D2 and this one is D3. Like that, it has updated by itself automatically wherever it is needed. So this is how we need to annotate. And now I'll go to the design and click on the convert schematic to PCB layout. Hereafter, the same principle. Let's start with that. Alright, now you can see that the complete PCB for a line follower robot is ready. In fact, the most important thing is I have used a 2-layer PCB designing in this, but I have not used any SMD components. All are through hole components, but using a 2 copper layer, top copper as well as bottom copper, I have designed the entire PCB. So this is how the PCB looks like, and you can notice that these IR LEDs are placed on the corner side. Why? Because we want to monitor these sensors data when they cross the line. So that's how the line follower robot works actually. I hope you understood the concept, and I hope you understood the placement of these components and designing all these things. And if you go for the photo view of this product, this is how it looks like, a top side and a bottom side. And if you go for a 3D view, this is how beautiful this looks like. In fact, we do not need to have to add a heat sink for these MOSFET. Why? Because it is not going to consume as much as power these MOSFETs get heated. Why? Because these MOSFETs are meant for 40 ampere of a current rating, and these motors consume less than 1 ampere. Of course, this is a overkilling design. Actually, we need to select a MOSFET which will be having a max to max of 2 ampere of a current rating. But right now, as a beginners and as a easy for us to design this entire project, we are using a IRF 540, which we have designed in our previous tutorial. And we need a heat sink for this 7805. Why? Because the entire device or the entire product may consume more than 1 ampere. That's why we need to have a heat sink for 7805. This is how the entire circuit looks like in the 3D model, and this is how in the PCB layout. I hope you enjoyed the entire tutorial, and I believe you learned something new in this particular tutorial. Consider subscribing to our channel Linked Frequency. Feel free to comment your questions in the comment section. I am very happy to answer your question at any point of time. See you again in the next video. Until then, tune yourself to make a difference.